Hi, my name is Iman Durrani, and I'm a junior at the University of Maryland.
I'm Saki Bazraf, and I'm a sophomore at McGill University.
And we decided to go ahead and create CoughDrop, which is an app that helps you get tested for COVID online.
So we kind of came up with this inspiration by looking at how difficult it is to get tested in some places, specifically if you're living in a rural area or a place where there might not be accessible roads. Um, Typically in those kind of places, people do have some sort of internet connection, so we decided why not make a testing system where people can get access to um, testing online.
So, our web app allows a user to upload an audio file containing the sounds of their coughing. It can be either a forced cough or one that's caused by a respiratory illness that comes more naturally, up to our website. And upon pressing the submit button, the audio file is processed, padded, and inserted into our trained model, which then predicts the likeliness that the audio file contains coughing caused by COVID-19. This information is then displayed for the user to see.
So we built it by first finding some data. So we found Kuswara right here. And this is just a database of a bunch of different people coughing and CSVs with their positivity. Then we went into Python and we made a data processor where we basically went through all of these files and we processed the data using a library called Librosa, which is used for sound processing. Then we use pandas to get the CSV file data. So whether a sound file is associated with a person who's healthy, has COVID, or was exposed to COVID. So we pack all of those into two, arrays, which we serialize. And then later on, we train it in Google Colab. So we have our Google Colab right here. And we trained it here. It's kind of messy, but this is where we trained it. We like mounted it with Google Drive and everything. So then once we trained it, we had our models. So 3 of these right here. And then we render our model into Flask, where then we can access it. So you start at the home page, right? You choose a file. So this is typically like a pre-recorded audio file. So you can cough into like a computer or a phone or something, record it and upload it into this website. If we go to desktop, we find cough and we submit. And then it tells you your positivity. So we kind of made the network using PyTorch. And it's just a simple like feed forward model, which we spent like 30, 40 minutes just training on Google Colab. And that's about it. That's kind of how the whole thing works.
Yeah, so some of the challenges that we ran into was that we were unfamiliar with a lot of these processes. So our first challenge was that we were unfamiliar with Librosa and audio processing, which meant that our data processing steps took a lot longer than we anticipated. Through intuition and a lot of Googling and just researching, we managed to process all of our data. Our second challenge was that actually training our network on our data. All of our computers were relatively slow, which increased the runtime a lot. So training our model on our own computer was taking forever. So what we did from there was we decided to upload our serialized input data and expected outputs to Google Drive, mounted it to Google Colab, and then trained it from there. Once the training was completed, we were able to download our serialized model and then mess around with our architecture to test different models. Our third challenge was creating the actual web app. None of us had a lot of experience with creating web apps reliant on a backend component, so we ended up utilizing Flask for the first time to create our web app.
So this is CoughDrop as it is right now. And ideally in the future, we'd like to continue working on this thing. So we'd like to improve our model, implement something, or implement ensemble learning, for example, which is basically just stacking a model on top of a bunch of different models. And those other like models under that top model might, for example, look at things like vowel phonation. So like how a person says the vowel ah, or how a person is breathing, or how a person is coughing, and using all of that information to then make a decision so that's much more accurate. And another thing we'd like to work on is to make it much more accessible to people who don't speak English. So according to the Harvard Business Review, about 1.75 billion people speak English, and the population is like what, 7 to 9 billion. So the large majority doesn't speak English, meaning our project is very limited in who can access it. So ideally, we'd be able to translate in multiple languages so a lot of different people can access this super useful resource.
Thank you so much. We hope that you guys like it.
Awesome, thank you.